Yeah, thank you guys. It's my first time hosting one of these, so I appreciate your patience. I'm still a little new to this team. If I haven't met you, hi, I'm Mallory. I use any pronouns. If I have met you, it's nice to see you. Um, and today I am going to walk us through a couple bits of using your raw data, which I know some people in the cohort broadly and even in this call already do all the time. And some people are like, whoa, I didn't realize I had access to that. Um, but yeah, so as Ryan suggested, getting access to your raw data is sort of the first step of working with your raw data. But we are going to go over where to find the raw data, as well as a couple of examples of working with and poking at the raw data in Excel, SPSS, briefly talking about Jamovi, and then are in RStudio. But first, again, where to find the raw data. So the right place to look is the institutional Dropbox, which you were hopefully sent when you first got access to your raw data early on in your participation in COVES. I cannot unfortunately link you to your individual Dropbox at this moment because it is institutionally locked so that you only have access to your data and nobody else has access to your data. But it should look something like this. This is ours here for the Museum of Science. And so it'll have a couple of different files in it. And what's important to note here is the fact that it's got a month and a year in the title. So these say December 2024. That means that this set of data files includes all of the COVES data that the Museum of Science has collected from the beginning of their COVES participation to December 2024 is the last month inclusive that is in those files. So it's a little confusing. There are three files. The most complete file is this .sav file here. .sav is an SPSS file type primarily. So if you're working in SPSS or if you're working in R or Jamovi, this is a great file to download to work with because it will have the numbers of your data as well as labels that tell you what each variable is, which is always handy. Um, if you're working in Excel, though, a .sav won't open. And I know a lot of people will probably start in Excel. It's pretty accessible. Instead, I urge you to download this values.csv here. The only difference between values.csv and labels.csv is that the values is those number values and labels tells you what each variable is. Um, you can get that label information either by opening up this CSV as well and referring back to it, or by referring back to some other resources that I'll mention in a second. But this is going to have sort of those juicy numbers that you want to work with. So the values.csv is the best to work with in Excel. Um, Again, your data file contains all of your raw data up to the month listed in that title. If you wanted to just look at a certain time period, a month, a day, a year, a week, whatever you would like, you can filter, and I will have us look at that in Excel in a minute. Once you first get your raw data downloaded, I like to open it up in Excel because, again, Excel is really accessible and it's a great way to get sort of a overarching picture of what we're looking at. So when I open Excel, I'm looking for, I actually personally have downloaded the November 2024 files and not the December 2024 files for use in this webinar. It shouldn't matter either way. But when I go to open it, the first thing I get is this wacky text import wizard. I just saw this for the first time today. I don't know why, but if you are getting something like this, it's important to know that this is a delimited file. Um, Delimited means that the sort of thing that is separating all the important bits of information is a comma. So you can see here that it says the Museum of Science, comma, email, comma, string of numbers, comma, string of numbers, comma, date, comma, time, etc. So that comma is showing me that there's like a break before each observation. So I tell it it's delimited, and then I make sure to tell it that it's delimited by commas. And now you can see it's split it out into discrete variables. So once I do that, um, this is sort of the overview. This doesn't matter, but this is sort of the overview, which is super overwhelming, I recognize, especially if you have not worked with data before a whole bunch. This is like a lot of numbers, and why is it doing all this stuff? But important to focus on, this first row is always going to be the variable names. And so if you're confused about anything, refer back to this. And if I'm looking and I'm thinking, hey, metadata operating system, what is that? I could probably figure it out. It says operating system, and the options are like Windows and Mac. Um, or maybe I'm like, what are all these timing variables? What is X good order? What do all these things mean? We can go back and look at the labels file in the Dropbox, as I mentioned, and that will usually explain more. But the team has also been working on a new resource called the Question Library, which will be made available for you all within the chat of this call, I hope, as well as in um, conjunction with the recording for this call, as well as on the website. It will be flooded a bunch of places. Hopefully, it won't be hard to find. But this resource has been created and curated. It's just a sheet, a spreadsheet in Google Drive. But the COVES question library is designed to have basically a big list of all of the questions that are on the COVES survey. And you can choose whether you're a science, art, or art bridges site, and that will show specifically the questions that can change slightly depending on your museum type that are on your survey. These will not be your site-specific questions, but they will be everything else. And so if I'm confused, for example, about what metadata operating system is, I can say, where is it in my raw data? This column will tell me the name of that variable in that raw data file that I'm looking at over in Excel. And I can find metadata operating system, and it'll tell me, oh, this is a piece of metadata that our survey software collects. That is the operating system that is running the browser that is hosting the survey. If I'm confused about X good order, I can find that all the way down here. I could even, Control F and type things in. This tells me the name of it is exhibits working. This is a 0 to 10 rating on the statement. The exhibits we tried were in good working order. So now I know what this means and I know how they're responding to it. Another useful example here is that sometimes we have multiple choice questions that our participants can pick from that say things like, how old are you? 18 to 24, 25 to 34, etc. That is our age variable here, age 1. And if I am looking at this in my raw data, it can be a little confusing. Specifically, if I go to age 1 here, you can see, I scroll down to where there's actually data for it. Age 1, what does a 3 in age 1 mean? That's not really, I don't think they're 3 years old. That's probably not that helpful. If I go here to the question library and I find age 1 in the question library, I can see the question is what is your age? And I can see that a 3 means that they're selected the 25 to 34 option. So this helps me figure out what different numbers refer to in terms of the response options to the question. And again, these base questions, there's a different version for science, plus art, and ArtBridges sites. There's also this fourth tab here called the question library. The question library is a bunch of completely optional questions that not every site is going to want or need to include. But some sites do. And these questions can be inspirational for you if you are looking for new ways to capture information from your visitors. If you aren't sure how to write a question to get at the information you want to learn, or if you're just maybe feeling burnout on codes and you're like, we're not getting anything that we're really using out of this, what can I sort of do to refresh our survey? This is a great resource. It has a bunch of anonymized sample questions that are actual questions that sites have asked on COVES. Some of these, like gift shop or cafe restaurant, are things that will probably be turned on for you by default if you have those options. Others are free admission programs. Are you affiliated with this local university? What's your favorite thing you did today? Do you have anything you'd like to see that we don't have? All sorts of stuff. As well as the same things, the response options, including potential examples. Obviously, these can be changed, and where and how it would show up in your raw data. So if you are looking for a way to switch up your survey, give this a look, give us an email. Obviously, we can't do anything until you let us know that you want to make a change, but this is a great resource to refer back to. And these first three tabs here, depending on what kind of site you're working with, are also great options for referring back and making sure you understand where things are in your raw data. It's a great tool to help decode the sort of nightmare that is this giant Excel sheet where there's just a bunch of numbers everywhere. Um, and so I'm going to go through a couple of use cases in Excel with this data. The first thing I want to show us how to do is how to filter. So I mentioned that if I want to look specifically at a specific month, I can filter my data so that I'm only looking at that month. If I was doing that based on time specifically, I could go here to the date column. It shows these as a bunch of pound symbols. I don't really know why. It's one of those quirks of Excel, but there is data in here, as you can see. It's up here at the top. It's changing as I go through. But if I select this column by clicking on the very top of the column, and I can sort and filter, I can sort oldest to newest, newest to oldest, or filter, and then you can see it's created this little drop-down filter. And automatically it wants me to choose which years I'm interested in, which is great. So maybe I only care about the calendar year of 2023. So I only want to look at the year 2023. Now you can see if I look through here, instead of showing me a bunch of 2024 options, it started me in January of 2023. And there are no 2024 or 2022 options in here at all. So that's super useful. And if I run analyses and calculations now on this data, now that it's filtered, it'll run it on just the filtered data, which is awesome. You could also filter based on other things other than date. If I wanted to turn this off, I can hit clear filter. Maybe I wanted to look at, for example, this language variable. So this language variable, if I go back to my question library, language here. It's the language that the survey was taken in. There isn't a how do they answer here, but for clarity, the most common option will always be English. And the only other language that we offer the COVES survey in is Spanish. So, oh, that's a sneak preview for later. So if I introduce a filter here to this column, selecting a whole column, sort and filter, filter, maybe. No, there we go. You can see I have a 1, which is going to be English, and 2, which is going to be Spanish. So maybe I just wanted to look at my Spanish surveys. I know there's not going to be there very many, but you can see there are a couple, and maybe I just wanted to look at the Spanish speakers here. So that's another example of filtering that you could do to look at specific things, specific age groups, people who took the survey via QR versus staffed method, people who visited at a certain time or spent a certain amount of time on the survey or in your museum or anything at all. You can really get creative with filtering, very handy. Yes. Another thing to notice while we are in Excel looking at our data is something that I call one-hot encoding. So for example, there are questions that we ask on the COVE survey that look like, which of these did you see or do at the museum today? Select all that apply. And that select all that apply means that instead of a 1 being I went to see exhibit A and a 2 being I went to see exhibit B, that's not going to work if they went to see exhibit A and exhibit B, because then it's going to be, well, like a 1.5. So instead, in order to allow participants to select multiple categories for one question, we do what's called one-hot encoding. And you can see here an example is this motivations question. So we have a bunch of questions that ask why you visited. You visited to support the site, to relax, to spend time, etc. And participants can select up to 2 different motivations. So you can see that this person selected motivations to support the site and motivations, something fun to do for yourself. So there's a 1 in each of these columns, but there's no value in all these other ones because these were not ones that were selected. So this allows multiple different response options to be selected by giving them each their own column. But it's important because that matters when we're looking at the data. It can be confusing to see a whole bunch of these empty columns here. What's important is that if I wanted to, I could, for example, add up all of the ones in this spend time column And I could do the same thing for all these other motivations, and I can see which is the most common motivation for visiting my site, and which is the least common. Another piece of Excel functionality that I wanted to touch on is pivot tables. So pivot tables are a great way to do something very similar to what I just described, which is to look at the sum, the average of different data in our data set, just to look at. We're not running any fancy statistical tests. I'm just, looking with my eyeballs at what's true about the data, but I am overwhelmed by this giant, massive spreadsheet, so it's important for me to be able to summarize it into something cleaner. So looking back at our age variable, which as I mentioned before, has a bunch of different buckets that people can select their age from. I'm going to go back over to where it is. Here's age, which is our old one. If I go to age one, there we go. If I go here, I can select the age one column. And for any column that I want to do a descriptive table on, I can go to insert and I can go to pivot table. And it can either put it on the same worksheet that I'm working on, or I prefer to do it on a new worksheet just to keep things clean. And you can see at the bottom here, it's open a new worksheet, and here's my pivot table. It doesn't look like anything yet, specifically because I don't actually have the age variable selected. Once I select it, you can see it's got the 2, 3, 4, 5, 6, 7, 8, the different response options, the different buckets that they can put themselves into. If I don't remember what these mean, I can go back to my question library. For reference, they just go in increasing age order, but we've removed under 18s for you already, so those never make it to your data set. That's why there's no one. If though I wanted to see how many people are in this 5 category versus how many people are in this 8 category, I have to take my age variable here for the pivot table and bring it over to values. And now you can see that it's counting up everything. But this is still a little messy. I've got people who didn't respond at all or left it blank. This is because this wasn't the age question we always used. So for people in this data set who are back in 2020, they weren't asked this question, they don't have a response to it. I don't want to look at them when I'm looking at my table. So I'm going to deselect them here, the same way I would on any filter. And that just gets rid of them. And you can see it counts up all of these different categories and puts a grand total as well. The filters, columns, values, and rows are great to play with when you're looking at different variables that can be organized different ways. I think this is a great simple way to get tables like this here. If I wanted to, I could change this by going to value field settings. Maybe I'm looking at a variable and I want the sum or the average or the maximum. I can look at the different different summary statistics, different summarizing numbers for different variables. Count makes the most sense for age, but it might not for whatever you're looking at, so definitely play around. And one of the really great things about pivot tables is that it's so easy for me to go back to insert and insert a pivot chart. Well, it would help if I had the right data. So if I have my pivot table selected and I hit pivot chart, it tells me what it thinks it should be. And if I hit OK, it has made a chart that already has all my data in it. So you can see it's got all those different age categories and it's already populated it with my actual data. And I can customize a lot of these words here. I can get rid of these things entirely. I don't need a title if I don't want one. I can change the colors and the styles. I can make them stripey or wacky, anything. So a pivot table converts to a pivot chart very easily, which makes it a very great way to visualize your data on the fly. So I can see that I've kind of got a bulk of my visitors are in this sort of this is like 18 to 24, and this is 25 to 34, 35 to 44, 45 to 54. So in between 18 and 55 is the vast majority of my visitors. So that's some super useful stuff to do in Excel. Moving on from Excel into SPSS, which is a slightly more advanced sort of statistical processing software. It is paid software. I have access to it through an institutional license personally. If you don't, unfortunately, it is paid. it allows us to do a lot of the things that Excel can also do in sort of a piece of software that is designed specifically for use with data. So I downloaded that .sav from my Dropbox because a .sav is a SPSS file type. It'll open it up here and it'll have some useful information for me that the .csv might not have. But you can see that at a glance, this looks pretty much exactly the same as when I opened my data file in Excel, which is good. It should. It's the same file. It has all of that same information. One nice thing about SPSS is that you can switch from data view down here at the bottom to variable view, and I can just look at, this is some of the information from labels. This actually has all this, this label field. So this tells me, oh, this motivation called, look here, motivation fun group is they went for fun or entertainment for group members or children. This has the exhibits in good working order. If I like really stretch this out, there you go. So all that information is in the question library is also built into the .sav when you open it in SPSS, which is handy in case you didn't want to flip back and forth between the two. Although this doesn't always have the factor information, it does usually also. So, for example, what's a good example? La-di-da.
CDO might be a good example.
CDO is not good. It is going to have, I mean, race here, for example, has all these different options. CDO has several different options, so you can see what they selected for if I wanted to know what CDO 19 was, because usually your site variable for the see and do question, what did you see and do today, has these really unhelpful names. And the question library can't help you with these as much, unfortunately, because I don't have site-specific questions in there. But if I was curious about what 19 is, I can go and see it's our garden walk exhibit. So that's also super helpful. Great to look at stuff this way. Know myself where I'm at. And just like in Excel, you can create really easy descriptives in SPSS. I wanted to, I haven't done this in a minute. What am I looking for? Descriptive statistics here. So if I left click my column, I can, I chose the method variable, which is the method they took the survey in. Did they take it on the QR code through the staff method, or we sometimes we'll have email data in here, and it'll show me the frequency. So 95 people took it on QR, about 1,800 took it on the staff method, that's the percent. This is all super useful information to have about various things. You could do the same thing with age like I did in Excel. And I could do that for any variable, and it would spit out a nice table for me with all this information, which is super, super helpful. I can also do slightly more complicated stuff. This is my output tab. I'm going to head back to my data. I can do slightly more complicated stuff if I wanted to in SPSS. I could compare different things, which can be handy. It is harder to do in Excel. Example I was curious about was membership. So if I find the membership variable somewhere in the back, also find using Control F, search string member was not found. Because I'm in a specific column that I don't want to be in. In any case, I don't need to be able to see it to do this analysis. So I can do compare means here under Analyze. And I am going to do an independent samples t-test. I'm not going to teach you statistics or what an independent samples t-test is, but basically I want to know if members and non-members are spending different amounts of time in my museum, right? Do members spend longer in the museum, or do they spend maybe less time per visit, but they visit more often? I don't know. So I want to compare members and non-members on stay time. So if I go to independent samples t-test, I can find my stay time variable, which is somewhere. So stay time in seconds is my test variable. That's what I'm wondering if there's a difference in. My grouping variable is membership. So I just have to find it. Hopefully, you are not at the Museum of Science and you don't have a million variables. Some sites will have very, very meaty, variable heavy files and others will not. I swear I found it before. The most fun part of data analysis is finding things that are hiding from you. Well, I'm having trouble finding it, so let's pivot. Instead, I'm curious if people spend more time in the museum on the weekend or during the week. So I do have this variable, and I could find this in my question library too, called weekend, where basically it's, are you here on the weekend or not? And then it wants me to define my groups. So for the weekend variable, it should either be 0, 1 or 1, 2. I'm guessing it's 1, 2, and then I can hit OK. Okay, so it's 0, 1, so I'm going to go back. If I checked my question library, I probably wouldn't have made that mistake. Pro tip. So instead, I'm going to divide my groups as 0, 1. The nice thing about SPSS is it will figure out what these mean. There we go. So I can look here just at this bottom report. For the weekend variable, it's either they were here Monday through Friday. That was about 1,000 people, or they were here Saturday, Sunday. That was about 600. And then the mean here is their mean stay time in seconds. So this is a bit ridiculous to look at because I don't personally think in seconds. I think in hours. So you could multiply or divide these by 60 a bunch of times to get minutes, to get hours, a whole bunch of different stuff. But this is just descriptive statistics the same way that this is. It's just telling me the average across these two different groups. This here is the t-test so that it's run. So the important thing here that you might already know about if you read academic papers in academic journals or only know a little bit about statistics is usually this sig variable here, which is short for significance. Typically, a test is significant or the difference is real if this is under a set value, often 0.05. So we can see that 0.004 is less than 0.05, which usually allows me to interpret that as meaning that there is, in fact, a difference between the two. If I wanted to know, for example, which one was higher, I could look here. I could see that mean difference is 712, which is positive, which means that people are staying longer here on the weekdays. I can also look back over here. I can see that people are staying longer on the weekdays than they are on the weekends. And my test tells me that that's the difference in significance, and this is the difference. And here's the size of the difference. It's about 700 seconds. And now I know that piece of information about my visitors, that visitors are staying longer Monday through Friday. So that's super interesting. I could also graph this similarly to what I did in um, in Excel. If I go to Chart Builder, oh, so Chart Builder allows me to drag and drop variables in here. Let's say I wanted to do this stay time by weekday, weekend. I just wanted to see it in a picture, or I wanted to share it with someone in a picture. I just have to find all my variables again, of course. So I can jump down here to where I know that stay time is. I can drag it over here. Or I could do. So I drag my chart type here. Maybe I wanted to know stay time in seconds is my y variable. It's sort of my dependent variable. And my weekday is what I want to sort by. So you can see here, it's not actually that big of a difference, as you might imagine. 700 seconds is not super major. Um, but if I hit OK, it has printed this graph, and you can see that the stay time is longer for Monday through Friday visitors than it is for Saturday, Sunday visitors. So I can drag and drop my variables in all sorts of different ways and into all sorts of different charts in Chart Builder. I'm not going to go super in detail because, in case you haven't noticed from how I'm floundering a little bit more here than I was in Excel, I'm not super advanced with SPSS. Definitely something for me to work on personally, but I do know how to do these basics that will get you stuff that you could report on, which is handy. Yes. So the next thing I wanted to talk about really briefly is this program called Jamovi, and hopefully someone will be able to link it for me. Jamovi is a program that is really similar to SPSS in its visual appearance, that sort of overlay that we've been working at this time that I've been working at this whole time. But it runs R, which is a coding language I'll talk more about in a minute, under the hood, and it's very, very easy to use, especially considering that R has a very high barrier of entry. It's a coding language. You have to know how to code. It's kind of a nightmare if you're starting from scratch. So if your institution doesn't have access to SPSS for whatever reason, but you still wanted to do some of the things that I just described, and run some statistical tests beyond what Excel is capable of, I definitely recommend Jamovi. Give it a shot. It's not as flexible as R, but it does pretty much everything that I want to be able to do in SPSS when I am working with Cove style data. So I think that Jamovi is a great resource. And again, it is free and open source, which is super duper handy. As I mentioned, it's technically run on R, which is a coding language. And because it is a coding language, that means it has a much steeper interface than these other options. Um, you have to know some of the basics of like coding as a concept, and there's a lot of like language intricacies that are hard for me to even really convey in this sort of shorter webinar format. We have a list here of recommended coursework and online boot camps that you might want to check out. Some of them are free, some of them are not. Um, but there are tons of resources on the internet, even beyond these that I've recommended here for learning R. Because R is a free and open source programming language, which is also super handy. And because it's a programming language, it gives you a lot of flexibility in what you can do and see. So I'm not going to spend a lot of time on it in case I imagine very few are experts in R here and are going to value that. But I will show you a couple of things that I do in R with COVES data. Um, I can do more complex statistical tests like linear regression. These can help me find differences like I was doing with my t-test, or predict things. So now, for example, if I wanted to look at that stay time by membership status, are members of my institution spending more time here? I could do that in R. This is what my R looks like. I have it kind of in dark mode, so this might not be what R looks like if you were to first open it up. The first thing I always do is load a bunch of packages and then import my data. So I'm going to do that now. Again, if this is complete nonsense and overwhelmingness to you, I apologize. It was to me too when I started, if that makes you feel any better. But this is called an R Markdown document, and I can type stuff outside of my code here that will show up as my document, but I can also write my code. So here I'm predicting, that's wrong. That's not what I'm doing at all. I'm predicting stay time for membership. So I'm creating my model, stay time predicted by membership, out of my data. And you can see it's less pretty, but it gives me a lot of these like t-values and my significance value, all these things that I was also getting out of my t-test in SPSS. It just is formatted a little bit differently. And you can see my p-value, my significance value is very small. It's less than 0.05. which means that this is significant. There is a difference between members and non-members in stay time. I did a bunch of extra stuff so that I could visualize this, which is not necessary, but I also wrote this code, which is going to create an image for me using ggplot, which is one of my favorite packages in the world. And you can see this is sort of what I've managed to create with this set of code. So we can see that members are in red and non-members are in blue. And stay time here, I'm using the bucketed version. So still increasing is longer, but you can see that non-members do tend to be in more of these longer buckets. So non-members are spending more time here. I don't know for sure why that is, but I can speculate, right? Like I mentioned earlier, maybe members come more often, so they spend less time here each time. So these kinds of pictures can help me get at that on top of just the statistical tests that I run. Another example of a statistical test you can run, which you could run in SPSS or R or probably even Excel, you could figure it out, is an ANOVA, which is analysis of variance. So, for example, we have a variable in this data set that is the method, and I've been mentioning it as either staffed or QR, but for a long time we actually also did email surveys. And maybe I want to know if there's any difference between all three of these methods, but there's three options instead of two groups here, like members and non-members. So I would run what's called an ANOVA. Um, and I can do that by naming my model again and predicting the duration, how long the survey takes to take, for example. So not the stay time, but like the amount of time spent on the survey by the method. And I can summarize it again, and you can see once again, it spit out this table that has a whole bunch of these different values. Here, instead of a t, I have an f value, and I have a significance that is, again, very small. And I can also run my post-hoc test. So now I know there's a difference between QR, email, and staffed, but I don't know if it's between QR and staffed, or staffed and email, or email and QR. That's what these post tests do. So you can see QR to email comparison is significant, staffed to email comparison is significant, staffed to QR is significant. So they're all different from one another. And I can visualize this one too by doing all this and getting an error, as you do. Let me get rid of this because I think that's what's tripping me up here. Coding on the fly. But you can see how email, these values are taken way longer than the staff survey do. It's hard to see the QR survey, in part because there aren't very many QR surveys compared to the number of staff surveys and the number of email surveys that we've collected at the Museum of Science. It might look different at your institution. I'll talk briefly about it later, and we will have like a more in-depth call about it someday. But we can see that all of these are different from one another. And I have the significance test sort of to prove it. There are a lot of fancy things that you can do in R that I'm like not even going to bother to show you because they take me a lot more time than I have in this call. If you are curious, I would definitely check out this website called the R Graph Gallery. Hopefully someone will link it. It has a whole bunch of different examples of charts that you can code in R. Um, Literally anything you could think of, including like a map, for example. I was curious about that. And it also has all of the code required to make every plot on the website. So that's super helpful. One thing that I like about R, as I mentioned, is an R Markdown. I can write all this code, but I can also write stuff outside of my code. And when I finish the document by doing what's up here called knitting, it gives me all these different options. I can knit to an HTML, PDF, or a Word. If I knit to HTML, for example, you can see it's working down here. Sometimes it takes a little while. But importantly, at the end of this process, it'll spit out for me this HTML or a PDF or a Word document that has the output of all of the code that I wrote, including graphs. So I can also turn the visibility of this off if I didn't want any of this nonsense here. I just wanted the pictures. And all the text I wrote outside of my code is showing up just as normal text. So if I did this into a PDF, for example, I could write a report to send to someone that has a bunch of our institutional data in it with all these pictures. right from R. I don't have to, take pictures out and put them in another program. So that's another super useful R feature. There's also more complex functionality that you can make interactive graphs. This Plotly package site is on the R graph gallery. You can see the scatter plot's got like, I can see each one of these. We have a couple different examples of what's called a Shiny app, which is sort of a web page type of situation that I can create straight from R. It can include all of these other features like interactive graphs. I won't go through these examples because I know we're a little short on time. But one of these has nothing to do with codes, the other one does. They're both cool. You can also interface with Python, which is a slightly more in-depth coding language. So if you were experienced in the Python language, but not R, for example, you can do a lot of similar things and you can get them to work with each other. And there's a tutorial for that linked here. So that's sort of my really quick rundown through all the different things that I do to work with R and to work with COVES data and different programs. As a reminder, don't get overwhelmed. That was a whole lot, and there's a whole lot more that I didn't talk about. Um, Go back to your dashboard if you are really curious about your C2 options. You can also look again at the Dropbox labels file, labels.csv. You could also look at the question library for variable names. One thing I want us to be cautious about, for example, when I ran that last test in R, I mentioned that there aren't a lot of QR surveys compared to my email and my staff surveys. When my sample size, the number of people who take my survey is too low, my analysis will be underpowered, which is a problem. So I would not actually want to run that test. So that was kind of a bad example of a test to run. And if you have such small numbers in the category of, for example, QR, you might want to exert some caution. If you have questions, shoot us an email, ask us now, whatever we can do to help you. I would love to help you. I really like working with raw data. It's like a big part of my job, and I would be happy to help you wrangle yours. And that is all that I've got. So if there are any questions that are pressing in the now, I have not been looking at the chat, but I would be happy to take them and go back to anything that I went over way too fast or whatever. And thank you also for listening.
Yeah, thanks, Mallory. So we've been monitoring the chat. There's been some good questions, some praise for the resources that you shared are for the rest of us, asking questions about Jamovi, but nothing that's come up specifically about the slides. Can definitely tell there are some people who are tracking directly with what you were describing, and some people who, particularly when we're going over the software, is kind of tapped out, which is totally okay
Hmm.
because getting here, right, don't get overwhelmed. It's a learning process. But definitely looking for some additional questions. So if you haven't posted anything in the chat, but it's on your mind, or now is the time when you can hop off mute if you'd like to, since we're through the presentation. That would be great too.
I'd love to revisit the library thing. That seemed like it was a new. I hadn't, I'm on the Coast team. I didn't even see that before. So like, can we go back to that way back at the start thing and look at that again, or the link? I guess you put the link in, and we can start there.
Yeah, and again, I'm hoping to really like have that link should hopefully be spread around. It will be hard to miss. Um, I am still sharing, correct? Yes, I am. This question library here. Um, was there anything in particular that you were curious about, Sarah, here, or just
I think this is something that we have talked about for a long time, offering or like somehow finding a way to compile or ask each site to share with each other. And so I feel like this is a really exciting uh new compilation of everything that we're working on. And I really appreciate you having walked through, you have multiple files. Here's why each one is useful, but also knowing like you can just hop into one and
Mhm.
get what you need to get from having the question library up to, rather than having to, you
Yeah,
know,
yeah,
look at things that are not color coded, that have no
yeah,
automated filters, stuff like that.
absolutely, for sure. Um, I see in the chat from Summer working in Excel and filtering by how long the visitor stayed at the museum. I could totally go through that. Um, so we have, Allison is mentioning, we have two different stay time variables. We have stay time 0, which is just in seconds how long, like exit time to entry time, the difference. And then we also bucket that into different categories, which if I was confused about, I could go back to my question library and find my stay time group. And I can see a 1 is 30 minutes or less, 30, 60 minutes, etc. So if I go back to Excel and find my stay time variable, so I've got stay time and I've got stay time 0. So if I wanted to look at just raw seconds, I could introduce a filter. Filter button is tricky when you have it on multiple things. You can see that there's a whole bunch of different values. This isn't really what I want. You can see that I can sort them from A to Z, and I can also, I believe, do a custom filter where it should be, maybe I want people who stayed for longer than 700 seconds, but less than 12,000 seconds. These are completely random numbers, I don't think in seconds. But this would introduce just those people in there. Or I could get rid of my filter on stay time 0, clear this filter, and I could go over to stay time, which is that bucketed one, where we've sort of done the hard work of figuring out what the seconds mean for you. Add that filter here twice. And you can see I've got all those different levels of my variables. So if I just go back to my question library, maybe I only want to look at people who stayed for less than an hour. So I only want to look at people with a 1 or a 2. So I can go back into Excel, my drop down. I don't want to select all. I only want to see 1 and 2. And now those are the people that I've got here. So these are the people who stayed less than an hour, and I can look at different variables. I can look at were they here on the weekday or the weekend, their demographic information, did they have a good time, their visitor experience, like their NPS and OER, that kind of a thing. Is that helpful?
Yes, thank you.
Of course.
So I just want to jump in now because we're just a couple minutes shy of the top of the hour. Thank you, Mallory, for this really enlightening presentation, both the top level, how do I find my data, what does it look like, and then the deep level, how do I use these fancy softwares. Thank you to everyone for being here. I do want to just say that this is a ton of information, and if you are new to using your data files, as we saw in some of the chat messages, right, like it can be overwhelming, even though our best advice is not to get overwhelmed. So this isn't going to be the only time we talk about it. We'd love to follow up with you, specifically around offering like some office hour type things. There's a lot of anomalies in the data files. You were just watching Mallory do an example for stay time, and the first rows that she looked at had blank values, right? When we went to the email method during the pandemic, we didn't calculate stay time because everyone was doing it after their visit. It didn't make sense. We couldn't calculate it. So there's so many things that are unique to our survey that you might have questions about. We would love to field those for you. If you want to do it via email, that's great. If you want to set up a short check-in with either the COVES team or the COVES Art Bridges team, please do. And additionally, we'll follow up with some options for office hours tailored to people who are super new to accessing or looking at their data file, and then some more advanced users. And we'll make sure to give multiple options so that everyone has the resources and supports they need. So this, again, was just the start of encouraging everyone to take that next step with their COVES data. So with that said, again, I just want to say thank you, Mallory. You're getting a lot of shout outs in the chat. Appreciative for all the work that you put into this, and shout outs to everyone for being here and sticking through the end of the hour. It was great seeing all of you. Again, we hope to hear from you, and we'll send out the February Community of Practice webinar invitation shortly. We look forward to seeing you all soon. Thanks, everyone. Bye-bye.
Thank you, guys.
Bye, thank you.